We're going to use a Maclaurin series to prove this. Yeah. What Maclaurin series might be used? There's a hint in the yeah, the E one. Yeah. So what's e to the x? 1 plus x squared over 2 factorial, x cubed over 3 factorial. Okay. 4 factorial. We know that from Maclaurin series. We did that earlier on. What do you think I'm gonna sub in or multiply it by or something? So I want to make it look like this part. So I'm going to multiply by I next. The x by I. Does that make sense? Oh. So I'm going to go EIX first. Oh, okay. Yeah? And then I'll do the pi at the end. EIX is, now what's the first one?
Would it be I?
Now look at the x power.
So it's just 1.
It's just 1, yes. So it'd be x to the power 0, so that would still be 1. But now we have ix, don't we? Now we have ix squared. So we'll come back to that. I know I can tidy that up a bit. Ix cubed over 3 factorial. Ix 4 over 4 factorial, and so on. So I know I can tidy these up because I know that I squared is something. So 1 ix is sweet. What's this one going to be then?
That's negative squared.
So ix squared is I squared x squared, isn't it? And that I squared is minus 1. So that's going to be minus x squared over 2 factorial. What's ix cubed then?
Negative ix cubed.
Yeah, so it's this, which is, we just found out was minus x squared multiplied by another ix, which would be negative then ix cubed. Yeah, negative ix cubed over 3 factorial. And what's the next one then?
It's just x.
Positive or negative?
Positive.
Yeah, because it'd be minus 1 times minus 1, I squared times I squared. So plus x for 4 factorial, and we could continue. Yep, all right. Before I do anything with pi, I'm going to see what I got. I notice that every second one is what? Is I, yeah, imaginary, yeah. So I have real, imaginary, real, imaginary, real, I for imaginary, yeah. So every second one, the next one is going to be imaginary. Now I'm going to bring in even more Maclaurin series into this. What is, let me write it out. Let me write it out a little bit differently and then you could tell me. So I'm going to write this out. I'm going to say I put all the real bits together. 1 minus x squared over 2i. So this plus x4 over 4 factorial. What would be the next one, this pattern? Minus x6 over 6 factorial, and so on. I'm going to say that's the real part. I'm going to do the imaginary part, so this is real. And then I'm going to factor out the I out of all the imaginary bits and just leave what's left. So x minus x cubed, x5 over 5 factorial. So tell me, your knowledge of Maclaurin series, what's this? Yes. So this is the Maclaurin series for cosine x. Very good. Cosine x. And what's that the Maclaurin series for? Plus I sine x then, yes. Because the I was taken out in front. Right. Now what was the thing I kind of ignored until this point? Pi. So we have E. Oh yeah, we have this wonderful diagram. I'll get rid of it now. Math is majestic, and that is me on a unicorn. Huh? This? Yeah, well, look, it makes it's not too bad now, but it does make a mess of the board, so I like to keep it clean, you know. So we have EIX. I'm just writing this up here again, so we have more space. But the only thing we didn't do yet, of course, is substitute in pi, because we want EI pi. not EIX. So we go EI pi, which means everywhere there's an x, I'm going to sub in pi. So that's cosine pi plus I sine pi. Tell me something about cosine pi. It is over here, yes, it's at -1. Tell me something about sine pi. It's 0. Very good, so we proved that to be true, which is kind of interesting. Unfortunately, the rest of them have missed that amazing proof, and they're definitely going to watch the video. I'll show you why it's useful to have this form as well. This is another form that we can write a complex number in, Euler's form. So there's Euler's form, there's polar form. So this in polar form, or well, the transfer between the two is this, and you see that over there. This is if the modulus is 1, yeah. If the modulus was something, it would be multiplied in front. So we can convert between the two. This is polar form. And then if you know polar form, you can convert to Cartesian form if you want. We're just going to look at, right, if it's e negative I pi over 4, the other example on the board here, how would I convert that to polar and then convert it to Cartesian? So, any idea what we'd write here and here? Briefly did this yesterday, I think, or Tuesday. What's the angle?
Negative pi.
Yeah. So the angle is negative pi over 4, and that theta is negative pi over 4, yeah. Plus I sine negative pi over 4. Now, can we convert that to Cartesian form then? Let's have a little look at where that sits. It sits down here somewhere, yeah?
Yeah.
So I need to know what's cosine pi over 4? Root 2 over 2. So is cosine going to be positive or negative? Positive, yeah. So root 2 over 2, and what's the sign? Negative, yeah. Negative root 2 over 2i. So there's the three different forms. Euler, polar, Cartesian. All right. Why is this one useful? Well, it's useful in a question like this other one we see on the board over here. So what happens if I have something like I to the power of negative I?
No I.
Yes, okay. So you're thinking probably you couldn't use Cartesian form because to the power of negative I, how would you even multiply that out? This one, you're kind of thinking maybe I use de Moivre's theorem, but that would also have an I in the middle here and an I in front. That's a bit messy. So I'm going to use Euler's form, which means this is the complex number bit. This is the number, I suppose, we have to raise to a power. What is this written? Well, written in Cartesian, it's, what, 0 plus just I, yeah? To the power of negative I, yeah? I don't want to do that out. So what's it in polar form then? Or cis form? Or cosine what angle? Where's I sit?
Oh, cis pi over 2.
Yes, pi over 2. I's up here, isn't it? On the imaginary axis. So pi over 2, yeah. So pi over 2 plus I sine pi over 2. Okay, it'd be a bit nasty to do de Moivre's theorem with a negative I here, putting it in. What angle is that? That doesn't really follow. So what we're going to do is we are going to use our new friend, Eulers form. So what is this in Eulers form? Don't do this.
Oh,
E to the I. This just this bit. Just
e to the negative pi power.
Well, we'll come there. Yeah, you're getting to it. What's just this now in Euler's form? So the angle is pi over 2. So it's EI pi over 2.
Yeah.
EI pi over 2 to the power of negative I. Now, this is useful now because I can use power rules, indices rules. So what is that combined? A power to a power.
Oh, you times it up, which is just...
Yeah, you just time.
Plus 1, so it's pi.
Yeah, so minus I times I is minus I squared. Maybe I'll write that out. E minus I squared times pi over 2, which is minus I squared is just 1, isn't it? 1. So it's just e to the pi over 2. And that's very easily converted back into these forms if required, but that is my answer. So that's a useful way, if it's raised to an awkward power or a complex power, you could use Eulers form or Eulers form and then just apply the power rule.
This is going to be on a quiz.
Yeah, it's going to be